Hi guys, this is the first video of the next unit, Unit 8. We are going to start talking about the mole, but first we're going to talk about your favorite, and that is Fencepost. I know how excited you guys are about this Fencepost. So I'm going to do a quick review on Fencepost, but not too quick because I know how much you guys love it. If you are like Mrs. Teagues, I totally get Fencepost, then you can just speed along to the next part of this video, okay? But if you need some more help with this, just let me know. So here's what I'm going to do. Let's walk through how to set up a fence post. So here's our first question. What is the mass of 90 average-sized apples if 1 dozen apples has a mass of 2 kilograms? So first you need to determine what is my given here and what is a conversion factor. Well, if it says something like per or for every something equals this, that is a conversion factor. It's something per something, okay? So if it says, what is the mass of 90 average size apples if 1 dozen has a mass of 2 kilograms, then, let me pull up my pen right here. Let's do red because that's easier to see. 1 dozen has a mass of 2 kilograms. That's a ratio right here. That's my conversion factor. So that means that my given is 90 apples. All right, so I apologize already. This writing is going to be really bad because I'm using a weird stylus. So 90 apples. All right, now I can't just put 1 dozen down here because apples and 1 dozen are not compatible units. So what I can do though is get apples into dozen. Well, how many apples are in a dozen? I hope you know that the answer is 12. So there are 12 apples in 1 dozen. So now apples is gone and I have it in the unit that I need it to be. Now I can use this conversion factor right here. So for every 1 dozen, it equals 2.0 kilograms. And now I'm going to check to make sure that that's the unit that they want. And they don't really specify, but they say mass, and kilograms is a mass, a unit of mass, so we're good. Now in your calculator, you would type in 90. You could do times 1, but that won't change your answer. And then times 2, hit enter, then divided by 12 here, okay? And that's going to be your answer. I don't actually have it on here, but I have no doubt that you would figure this out. So these units cancels, apples and apples cancels, dozen and dozen cancels, and we're left with whatever your answer is in kilograms. Okay, I should have a calculator with me, but I do not. All right, let's try another one. If 0.2 bushel, so not quite a whole bushel, is 1 dozen apples, and a dozen apples has a mass of 2 kilograms, what is the mass of 0.5 bushel of apples? So a half bushel. All right, well, let's figure out what is my conversion factor here, or maybe several conversion factors. Well, it says if 0.2 bushel is 1 dozen. Okay, that means if I have 1 dozen, it equals 0.2 bushel. That's a conversion factor. And I have a dozen apples has a mass of 2 kilograms. So that's another conversion factor. For every 1 dozen, it weighs 2 kilograms. So we're asking, what is the mass of 0.5 bushels of apples? That's my starting unit or number. So 0.5, I'm going to write B for bushel. Start my fence post. Now I need to get rid of B and bushel. So bushel has to be at the bottom here, diagonal from it, right? So I can get rid of it. So now I'm going to look and see what do I have that has bushel in it, and this guy does right here, 0.2 bushel. So 0.2 bushel is going to go right here. So 0.2 bushel for every 1 dozen. So I got rid of bushel. Now I need to get rid of dozen, and I've used this one already. So I see dozen is here. So for every 1 dozen, because a dozen is 1, for every 1 dozen, it has 2.0 kilograms. And so now I'm just going to double check, did all my units cancel that I need to? And yes, I am left with, kilograms. I am left with kilograms. which is a unit of mass. So we're good. So in your calculator, you type in 0.5 times 2, hit enter, divided by 0.2. You don't have to multiply it by 1 because that won't do anything. Your answer unit is going to be blah, 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 something kilograms. All right, let's try the last one. So let me, I guess I don't need to erase. Assume 2 kilograms of apples is 1 dozen. That's another conversion. 2 kilograms of apples is 1 dozen. And that each apple, so for every 1 apple, it equals 8 seed. That's another conversion factor. How many apple seeds, so we're looking for apple seeds, are in 14 kilograms of apples? Okay, so our start is 14 kilograms. 14 kilograms. All right, where else do I see kilograms? Right here. Okay, I'm going to put that in first, kilograms down here to get it to cancel. So let's see if I can do this. 2 kilograms is 1 dozen. All right, so we got rid of kilograms. Now, if I don't have dozen anywhere else, but I do have apples, so how many apples are in 1 dozen? I hope you, again, all know the answer. For every 1 dozen, dozen has to be here to cancel it, there are 12 apples. Okay. Now I can put in this conversion factor right here. For every 1 apple, it has 8 seeds. 1 apple, that cancels. It has 8 seeds. Again, I'm really sorry about this writing. All right, and then I'm going to check and see is that the unit they want, and yes, they want seeds. So in your calculator, 14, you can skip over the 1, times 12 times 8, hit enter, divided by 2. And that gives you your answer. And what do you think the unit is going to be? Seeds. Good. All right. So now that we've had a nice warm up on Fencepost, we'll get more into that in the next unit. Here's our joke of the day, because I know you guys have been missing these. What do you get when you cut an avocado into 6 times 10 to the 23rd pieces? Guacamole. Okay. I am only going to do the first part of this lesson, which is calculate the molecular mass of the compound. I'm going to split the next video up for this one, moles and particles, and go from there. All right, so calculating molecular mass is really easy. It's just the mass of all the atoms in a molecule combined, okay? All you have to do is you take subscripts, multiply by each atomic mass, and you get this from the periodic table. So those decimal numbers, so carbon is 12 and oxygen's approximately 16 and so on. If there is no subscript, then it's just multiplied by 1, okay? Then you add them all together. So subscript times atomic mass, and then add those numbers together. So let's try this. So we have 2 examples here. We got glucose, C6H12O6, and then we have this thing, which I don't know what the common name is. But first step is, and you do not have to do all these steps, guys. I'm just showing you how I do this, okay? A lot of you guys are going to do less steps. But step number 1, if you're, walking it out, is how many of each thing. So I'm just looking at the subscripts here. There's 6 carbons, so 6 carbons. There's 12 hydrogens, that goes there, and then 6 oxygens right there. So these are my subscripts. Next is I'm getting the masses from the from the periodic table. I like it if you at least round to 1 decimal place, which, as you can see, I really didn't do here. Most of these actually are fairly accurate. This would be 12.01 and this one would be 1.01, but this one's fine. So if you keep at least 1 decimal place, that's fine. That's preferable. If you round to the nearest whole number, you can do that as long as it's not like 0.5 or 0.6 or 0.4, because that's going to change your number. All right, so now I'm going to take the atomic mass and I'm going to multiply it by the subscript for each one. So we got 12 times 6, 1 times 12, 16 times 6. So that goes there, okay? We're going to get totals for each one. So again, subscript times mass, subscript times mass, subscript times mass for each one. Then I'm just going to add these 3 numbers together. And so this is my molecular mass, or sometimes called molar mass. If I say molecular mass or molar mass, I'm talking about the same thing for this, okay? The unit for this is going to be grams, per mole. So what that means is if I had a mole, and I'll talk about a mole in the next lesson, if I have a mole of this compound, glucose, it will weigh on the scale 180 grams. So for every 1 mole of glucose, it weighs 180 grams. Okay, that's the unit for this. All right, now I want to show you what do you do when there are parentheses like in the next one. So here we have NH3 in parentheses with a 2. When you have a subscript on the outside of parentheses, you multiply through. So you do 2 times 3. Do not add. Please don't add. Okay, it's 2 times 3 and 2 times an invisible subscript of 1. Okay, sulfur's just one of them and oxygen's just one of them, so it only affects what's inside of parentheses. So for here, it's showing you I have 2 nitrogens, I've got 6 hydrogens, 1 sulfur, 4 oxygens. These are the masses from the periodic table, and yes, I did not keep a decimal place, which I should have. That's the appropriate way to do it. At least keep 1 decimal place, please try to. Then you multiply subscript times mass for each one. So for nitrogen, it's going to be 28, for hydrogen, 6, so on and so forth. Then you just add them all up, and you get, for this compound, 130. And again, the unit is going to be grams per mole. Okay? All right. If you need further instruction on this, or you just didn't quite get something, please let me know. The assignment is that I'm going to post is going to combine this instructional video and the next instructional video. So there isn't currently anything for this right now. I'll let you know if that changes. So send me an email if you guys have any more questions. Take care, guys.